Welcome back, students. We have already covered from our previous videos asynchronous counters, and there are series of lectures already available where we have covered up counter, down counter and up down counter. Now in this particular video we are going to discuss synchronous counter, that is the second category of counters. And again from the series of videos that would be coming, we would be covering again the up counter, down counter as well as up down counter. Then there is one truncated counter also we have basically studied in some videos, and that was a decade counter. And previously we have designed it using asynchronous logic, and now we will be designing it again with synchronous logic. So that is basically the schedule that we will be following in the coming videos. We'll be mainly focusing now on synchronous counters. Now if you have seen my previous video regarding introduction of counters, then you must have seen there are few differences between the design of synchronous and asynchronous counters. And the most highlighted difference is, if it is an asynchronous counter, then clock pulse is given to only the first stage, and that stage is basically the LSB. And while as if it is a synchronous counter, the clock pulse is given to all the flip-flops together. So if we have to see diagrammatically also, so this is the diagram. This one is asynchronous counter, and you can see here the clock pulse is given to only the first stage, this first stage, and this stage is then LSB. Wherever clock pulse is given, that is LSB for us. And then if we look at the second stage, then clock pulse is coming from Q. The output is acting as a clock. Again from the previous videos you must have seen, if this clock is coming from Q, it was an up counter, and while as if suppose this clock would have been coming from Q bar, it would have been acting as a down counter. And both the designs are right now asynchronous. So this one already we have covered. Now in this video we are focusing on synchronous counters, and you can see here the clock that is being provided, it is given to both the stages at a time. You can see here the clock is given simultaneously, it is given simultaneously to both the flip-flops. So there would be no ripple in it. Then again if you remember the previous video regarding introduction to counters, there is one more highlighted difference between synchronous and asynchronous. If the design is asynchronous, then to design this asynchronous counter, it is relatively easy, while as synchronous is difficult to design. And why it is easy, you must have got the idea from the videos that we have already uploaded on asynchronous counters. You have to simply you can say add on the stages, and you have to propagate this output as a clock for the next stage, and you can design it for 2 bits, 3 bits or even for 4 bits. So the design is very easy. But if it is a synchronous counter, then the steps that we need to follow to design are different than what we do in asynchronous. So to understand that design process, we will be starting with one very simple problem, where we are being asked to design a counter, that is an up counter, and this is for 2 bits we'll be starting with. And one more thing, we are using here T flip-flop. Now what is the design procedure? You will now I want you to pay attention towards the design procedure, because this is very important. So we'll start a solution. Now what we have to note down, if it is an up counter for 2 bits, then number of bits are 2, so again the number of flip-flops are also 2. Then number of states are how much? Number of states are 2 to the power n, that is 2 to the power 2, so that is 4 states. And those 4 states, since it is an up counter, are 0 0 0 1 1 0 and 1 1, then it should move back towards 0. Then how to design it? So you have to remember this particular procedure. You have to write present state, then you would write next state, and then you would write flip-flop inputs. Then you would write flip-flop inputs. Now suppose we are starting from 0 0. We will then write the output name. Suppose this is Q1 and Q0. So this will be Q1 plus and Q0 plus. And we are using flip-flop T because it is given in the statement of the problem. We have to use T only. So we will write T1 and T0. Now the sequence is an up counter and we have to follow this particular sequence given here. So see how do we write it. You will write 0 0 here. Now after 0 0 the next state should be 0 1. So you would write here after 0 0 0 1 will come. Now after 0 1 what is the next state that you are expecting? The next state is 1 0. So the moment you are actually moving from 0 1 to 1 0, your present state becomes 0 1 and the next state becomes 1 0. Or you can say in the previous clock pulse, whatever was the next state, that will act as a present state in the next clock pulse. So the same procedure here. Then 1 0 will move here. So after 1 0 the next state must be 1 1. So it is acting as up counter. You can see we are moving from 0 to 1, 1 to 2, 2 to 3, and from 3 we should move back towards 0. So this 3 will now again come here. This 3 will come here. And after 3 we are moving back to 0, so we will write here 0. So this is the design procedure of writing it. So we are ready with the present state and the next state. Then we have to basically complete the other two columns of T1 and T0. And for this we should know the excitation table. Excitation table states with your outputs given, what are its corresponding inputs. And you know for a T flip-flop it is like an XOR gate 0 1 1 0. Now again very important, if we have to complete this particular column, if we have to complete this column of T1, then what we will do is you will do, I will note it down here, T1 is equal to Q1 XOR Q1 bar, sorry Q1 plus, and similarly T0 is equal to Q0 XOR Q0 plus. So once I am completing this T1, I will look at this column and I will look at this column. Now see here, 0 and 0 will make it 0 only. You have to see this table, XOR table. So 0 0 is 0. Now 0 1 is 1, 1 and 1 is 0, and 1 and 0 is 1. So this one is completed. The same procedure I have to basically follow for the T0. So T0 is Q0 XOR Q0 bar. So what you have to look at is this Q0 and this Q0 plus. So just look at these two columns. Now see, 0 and 1 is 1. Again 1 and 0 is 1. 0 and 1 is again 1, and 1 and 0 is again 1. Okay, so but what I am basically doing here is XOR operation only. So my table is basically complete. Now the next step after this is my K-map. You have to wait for the second video where I will be completing this design. So till then you can revise your notes. God bless you all. Thank you.